Let's go to LeetCode 3203. Find the minimal diameter after merging two trees. For this question, it gives us two trees and ask the minimal diameter after merging two trees. So the diameter of a tree is defined as the length of the longest path from one node to another node, right? And there are several cases. One is that the tree one, right? It is a very big tree. For example, it has diameter which has a very long diameter, right? And a tree two, possibly it is just a small tree, right? In this case, even we merge the tree to tree one, if we get the smallest, right, it will not change the smallest diameter. Smallest after merging, we can have this kind of diameter to connect, for example, here, right? It will not increase the total diameter because the total diameter will still be on the first tree's diameter path, right? Another case is that, for example, the tree two is a big one. Then tree one will not change to tree two's diameter length. The third case is that the tree two is also a long tree, right? And if we, for example, we connect, for example, this is 1, 2, 3, 4, 5, right? If we connect, for example, this node, and this is 1, 2, 3, 4, 5, 6, 7, and we connect to the middle, right? We select the middle node. What we get is that the diameter is now 1, 2, 3, and we can have 1, 2, 3, 4, right? So in this case, the diameter will use half of the tree two and also half of the tree one, right? And plus one have the connection, right? So the thing is that if we know how to get a tree's diameter, so the result will be max of diameter one and diameter two, and that is half of diameter one plus and connection, right? Plus half of diameter two, right? And we know the diameter is get the longest, so this will be half of diameter plus one divided by two, and half of the um, uh, diameter two plus one divided by two, and the plus one have the connection, right? So because if this diameter it is 7, right? We'll get a half that will get the 4, right? And if this 5, and what we get is get 3. And so we'll get 3 plus 1 plus 4, right? So this is greater than 5 and also greater than 7. So the result is 8. So the result is what we are looking is that return the max of diameter of tree one and diameter of tree two and also diameter tree one plus 1 divided by 2, right? And plus 1, this is connection, and plus diameter tree 2 plus 1 divided by 2, right? So this is what we are looking for. So that this question becomes how to get the diameter of a tree, right? So we can write some kind of helper function, right? So let's say inter R1 equals, so we can have a helper function, right? And age is 1. And int R2 equals helper age is 2, right? Then we return max max R1, R2, and another one is R1 plus 1 divided by 2, and plus 1 plus R2 plus 1 divided by 2, right? So we need to write the helper. Um, the first thing is that we need to have some corner cases, right? If this kind of age is equals not, or age is not less equals 0, we're going to return 0, right? Um, Here, this tree it will give us those kind of age, right? So we need to convert this kind of to some kind of possibly a map or list of list of sets, right? Map of keys are integer and the value is a set. So let's write the map, right? And set integer, because we are not sure. Now, yeah, it is consecutive, so we can also use list, right? But let's use the map here. Tree equals new hash map. So the key will be the node, and the set of the value is the set integer is the neighbors it connects to. So what we do is that for every edge, right, in edges, we're going to have tree compute effect sense age 0, and the k goes to new hash set add age 1. In another case is that we should put both, right? So both node will have age 1 and age 0 as well. And if we have this map, right, we can write return give a diameter tree, right? Um, we can put a 0, right? Because it starts, you see, every tree. We can put a 0 actually in a diameter function, right? Um, Let me see. We can write this. Call this helper function called diameter, get a diameter, right? And now we are going to, after we get this tree, we want to get this diameter, right? So get a diameter of a tree. There are several ways, right? Let me talk about first way is that we do two paths traverse. The two paths is that from randomly we picking a node from a tree, right? Randomly we pick a node from a tree, and we do for example we pick here. Let's have this tree possibly in this kind of shape. And we do BFS or DFS to find the from this node what is longest node it can reach. So if we do BFS, right? So we find possibly when start from here, and we possibly we reach this node, right? That is the longest from this node to this node, right? So if we random pick this one, we find a path, and we end at this node. And the second step is that we do this node is what we found, right? For example, N1, and we do another BFS from this kind of node to get the longest path, for example, this one, right? Then this green line will be the diameter of the tree. So these are two paths, right? So we can prove this is a correct approach. If, for example, we in the first pass for the orange line, right? If we use a shorter nodes, right? And we know if we use a shorter node instead of N1, right? So we know for this part, it will always be shorter than this common part in the diameter, right? So we know from this node to N2 are always smaller than the diameter. So the optimal is from N1, right? And also, if the green the the green line, right? If we get a shorter, and it will also smaller than the node for the N3 is smaller. N1 to N3 will be smaller than N1 to N2, right? So doing like these two paths, we know the diameter is that we randomly pick a node and do BFS or DFS to find the longest node, farthest node it can reach. And then from the farthest node, and do a BFS or DFS to get the farthest node again, right? In the second pass. So the total length will be the diameter. Let's write this approach using BFS first. So we'll have approach one, right? Approach one, two pass BFS. Okay. So we randomly start from node 0. Okay. So we can write an help function in BFS to return two results. Result 0 will be the farthest nodes, right? Far is the far is the node. And the result one will be our max distance. So for this BFS, because we want to reuse, right? We should pass the start because we use the first pass and to get the start nodes for the second pass, right? So we need a queue, right? For BFS, we need a queue. Int we call queue equals new array there. So we'll have that integer related equals new hash set. Then we'll have queue offer new int. We put in the queue the node and the paths, right? And a node, for example, star node, and also the length, right? We have the distance for this node. So at the beginning it is 0, and we're going to have related add started star node, right? And then we'll say, wow, this queue is not empty. Well, it currently equals to queue.put. Um, so because we want to get the forest, right? So that we'll say if let's have int node equals to current 0 and also int distance equals current 1, right? So we'll say if this distance, let's have a variable, right, called int uh, furthest, right? Furthest node equals let's set this one as star node, and also max distance, right, equals 0. So if this distance is greater than max distance, right? So we are going to have max distance equals this distance. And also we are going to have farthest node equals node, right? Then we look at its neighbors for int next in tree. So let's say if this tree contains key, right? This contains key. If the tree contains key, is node, right? Then we're going to if that contains, right, then we continue. Then we'll say for int next in tree get, right, get node. We'll say if this is already been visited, right, we should also continue, right? If visited contains next, we should continue. Otherwise, we'll set visited add next, right? And then we'll have a queue offer new int next, and distance should be +1, right? Because for our neighbor, our distance will add 1. And then return new int farthest node and max distance, right? For this question, we can also use BFS by layer, right? So because we want to get the longest distance, and the thing is that for the last, we need to get the size of the queue, and then use a for loop for the size. And but the thing is because we want to get a node, right? So for the last layer, you will say we'll also get a node, right? You can also have a, for example, a pre-node variable at the beginning, right? So that when we put out of the while loop, we'll get the last node. That will be the longest node we reach. So that is the BFS by layer. We can do that as well, right? So for the result, what we do is that we are going to use the first pass to find the farthest nodes. And then do BFS again to get the max distance. So we'll say result 1, right, equals BFS tree. And let's start from 0, right? And we'll have result 2 will be BFS from tree. And now, the first element is the first node, right? So we should have result 1 there. And in the end, we just return result 2, 1, right? That is the longest distance. That is the diameter. BFS is kind of slow, right? We can also use a two pass, right? To use a DFS way. So approach 2, right? So let's have approach 2. Approach 2. That is the two pass DFS. Okay. So for let's come write something called private int DFS, right? So also we'll get a result 0 as farthest node and the result 1 as mask distance. Um, so we need to pass this kind of tree and also star nodes, right? For DFS, we also need a parent node so that because for every tree node, it may have we go to its child or next, right? But the next is possible it is its parent, right? If the next is its parent, we're going to skip. Um, and in this case, we don't need the weighted set, right? So we're going to have int farthest furthest node equals starting node, right? And next distance for 0. So what we do is that for int next in feed it node, right? So we'll say if tree contains the node, right? Then for use for loop, right? Um, one thing is that if this next um, equals parent, right? We should continue. And we are going to have every answers, right? Equals EFX tree next and start node and starting node, right? So what do we say in this kind of DFS is that if this kind of answers 1 plus 1 is greater than our max distance, then we're going to have max distance equals answers 1 plus 1. And farthest node equals answers 0, right? And in the end, we just return new int farthest farthest node and max distance, right? So to pass the DFS is that we are going to have result 1, right? Equals DFS 3 0. We initially we set its parent as -1, okay? And then we're going to have result 2 equal to DFS 3. We are going to from the first pass the farthest node, right? So that is the result 1 0. And we also set its parent as -1. In the end, we just return result 2 plus 1, right? So this is a two-pass DFS, right? Um, we can have the third pass, third approach to do diameter of a tree, right? So the third um, third approach is that approach 3 is we we um we start from any node. Mm, because for tree, right, any node can be considered as a root node. So we can start from every node. Then for this node, it have a lot of charts, right? So we know a node for each chart, we are going to return two things. One is the longest path under this subtree. We call longest. Another is the um, deepest path under this kind of subtree, right? So for every subnode, it has two results. So we know that in the end, if we backtrack from a chart to the parents, we just need to get all of its child results, right? So the deepest of this node will be the deepest of the child plus one, right? And the longest under the new tree, right, should be the maximum amount of this kind of longest. And also, there is another option is we find the deepest one and the second deepest one, right? And we add two. So this may also contribute to the longest path. So we have several options. Is every longest in the subtree, and also we have a deepest. The deepest is just we don't pass the root, right? We just from root to a leaf. The longest is from the leaf to leaf. So we find the deepest and also the second deepest, right? And also add these two parts and trying to compare with every longest in its subtrees, right? So this is just one path. It's like a divide conquer. So let's write this approach as well. Called divide conquer. Let's call it a DFS2, right? Because it is also an divide conquer. We can also like consider this as a post order traversal. We can also consider a special DFS, right? So we call DFS2. So private int DFS2. So we also need because DFS is that because we are using this map, right? When we go to its parents or go to its child, right? So if this is parents, we should try to ignore, right? Because when we for loop its neighbors, right? It's next. Our parents are we already traversed, right? So DFS2, the result 0 will be deepest, okay, deepest length, and the result 1 will be the longest that is diameter, right? Longest that is length. So result one is diameter. Deepest is that we just from the root to a from this tree's root to a leaf, right? So what we do is that we're going to have in deepest equals 0, right? And second, that's called deep one, right? This is deepest for 0. And deep 2, that is the second deepest, equal to 0. And longest equal to 0, right? So what we do is for every int next in tree, get a node, right? Um, Actually, we don't need to write if tree contains, right? Because for 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 of course this one we can ignore, right? Because this is a tree, and every edge is connected. Every node is connected by an edge, right? So of course you can write this line. If a tree contains key, then do something, right? But if we don't write this, it is fine, right? Still be correct. So then we are going to say if this kind of next equals the parent, we should continue, right? And for its subtree, for each child, right, we should have our answers equals DFS2 should be next. And start node, we should have a tree, right? Passing a tree in the start node. So what we do is that int d equals answers 0 plus 1, right? So what we do is that if this kind of result 1 is greater than longest, then we'll have longest equals result 1, right? So that is for every child. Uh, we compare each child's diameter first, right? Then we are going to have the depth, right? If d is greater than d per 1, then we'll have d per 2 equals d per 1, and d per 1 equals d, right? And else if d greater than d 2, right, we'll have d 2 equals d. So here, the longest, there is another option, right? The longest can be, the longest thing is just child tree. It can also be um, deep 1 plus deep 2, right? So in the end, we just return new int longest and deep 1. Uh, we should have deep 1, right? Deep 1 and the longest. So for this kind of approach, right, we just need to have int result equals DFS2, right? So we should have tree and that node. its parent is -1, right? In the end, we just return result 1. This start node is 0, right? This is answers, not result, answers. So we'll see. This this one pass will be faster than the two pass, right? Um, so we can also write DFS, right? For the time complexity, we'll say because we need to transfer every node, right? So it will be O(n) plus m time complexity, right? For Python, I'm going to write only the third approach, right? Just one pass approach. Mm, so we know we need a depth data diameter, right? So we need to have edges written into, right? So we'll say if this count edge is null, right? Return 0. Then we'll have tree equals default text predict set, because we want to have the value as set, right? So we are going to for every e in ages, we can have tree age e0 add e1, right? We also have tree e1 and e0. And we also need to define the DFS, right? So we need to define DFS. This is the DFS2 in Java code, right? So we need to have also a tree node up and a parent, right? So so what we do is that we are going to have result equals to DFS this tree, and our star node let's set as 0, right? And -1, and return result 1, right? So for this kind of DFS, what we do is that so we have deep 1, right? Deep is second, deep is deep 2, and the longest equals 0, 0, 0, right? And for next node, next node in tree node, right? So the next node equals the parent. We should continue. So we should have every answer, right? Answers equals DFS B and next node and node, right? So for this answer, right? Every answer we get D equals answers 0 plus 1, right? So let's say if um, if this answer is 1, right? That is the longest, the diameter of this subtree is greater than longest. Then we'll have longest equals answers 1, right? And we'll say if D is greater than D per 1, right? So I have D per 2 equals D per 1. This order matters, and then we'll set D per 1 equals D, right? Let's say else if D greater than D 2, then we'll have D per 2 equals D, right? And and uh, the longest, the diameter can be the diameter of each subtree or this D1 plus D2, right? So we need to have longest equals max longest and D1 plus D2. Yeah. So in the end, we return D per 1 and the longest, right? So this is the DFS. And in our main function, we just have R1 equals get diameter H is 1, right? And R2 equals get diameter H is 2. In the end, we just return the max of the string. So that is return max R1, R2, or R1 plus 1 divided by 2, right? And also plus 1 plus R2 plus 1 divided by 2, right? This is the early